Hello, and welcome to Ozone International's safety training video. As the global pioneer of ozone-based cleaning and sanitizing, Ozone International is dedicated to advancing the science of sanitation in the food and beverage industry with state-of-the-art, environmentally friendly technology. This short video will introduce you to the use of ozone in both the aqueous and gaseous forms. We will discuss your everyday exposure to ozone and compare that to the OSHA requirements and occupational standards for the use of ozone. Ozone is one of nature's most powerful oxidizers, which is approved for use as an organic sanitizer. Nearly all bottled water is treated with ozone, and most municipal water systems utilize ozone to treat drinking water. Ozone is a molecule composed of 3 oxygen atoms. Ozone is naturally produced when an oxygen molecule, or O2, is struck by UV rays. This is known as a photochemical reaction. It can also be struck by high-voltage electrical arcs, such as lightning strikes. The oxygen molecule is split into individual oxygen atoms, or O1. Then oxygen atoms unite with passing oxygen molecules, creating O3, or ozone. Ozone is very unstable, resulting in a short half-life. Since ozone is in a highly reactive state, the extra oxygen atom is released from the ozone molecule and binds with organic and inorganic materials upon contact. This reaction breaks down their cellular wall, causing the destruction of bacteria, viruses, yeast, molds, cysts, mildew, and many other organic and inorganic contaminants. Ozone's residual byproduct is pure and stable oxygen. Ozone has a long history of use. For over 100 years, mankind has benefited from the innovation of ozone technology. In 1840, ozone was officially discovered by the German scientist Christian Schonbein and proposed as a new substance in the air. In 1865, ozone's formula was determined by the Swiss chemist Jacques-Louis Souret as an activated oxygen, or O3. In 1893, ozone was first used for a water treatment plant in Ubaden, Holland. By 1906, France's first ozone water treatment plant had been installed. By 1916, there were 49 ozone installations throughout Europe, 26 of which were in France. By 1940, there were 119 ozone installations worldwide, with the first use in the U.S. at the United States Naval Academy swimming pool. In 1976, the Environmental Protection Agency approved ozone as an antimicrobial oxidizer. In 1982, International Bottled Water Association specifications approved ozone as an antimicrobial oxidizer for product and disinfectant for filler lines. In 1999, the Environmental Protection Agency approved ozone usage for surface and groundwater treatment. In 2001, both FDA and USDA approved ozone as a food contact surface disinfectant and for direct contact food surface disinfection. In 2002, the USDA National Organic Program approved ozone as a food additive and for direct contact food surface disinfection. So what should you expect? Ozone's odor is sharp and similar to chlorine and detectable by many people at concentrations as low as 0.01 parts per million in air. Ozone water is safe when used as directed and as part of a managed cleaning and sanitation program. Ozone has a distinct smell. It's the fresh smell after a thunderstorm. A small percentage of people may be sensitive to the smell for the first few days. This passes as users become accustomed to the smell of ozone. Ozone levels are monitored and kept at safe levels to ensure worker safety. Compared to chemicals such as chlorine, ammonia, and others commonly used in the food processing industry, ozone water is less likely to have dangerous reactions with other compounds and leaves no harmful residue on skin, in treated foods, or processing water. Ozone's residual byproduct is oxygen, whereas chlorine's residual byproducts include chloroforms, bromethanes, and other halomethanes. Ozone has many advantages over chlorine and other antimicrobials. Ozone destroys microorganisms much faster and effectively as compared to chlorine. Because of ozone's higher oxidation potential, its reactions take place several thousand times faster than those of chlorine for destruction of bacteria, viruses, yeast, molds, cysts, mildew, and most other organic and inorganic contaminants. There is no regrowth of microorganisms after ozonation, unlike ultraviolet and chlorine disinfection. We have discussed that ozone is one of nature's most powerful oxidizers. Ozone has been in use for more than 100 years as an industrial sanitizer. You are not the first company to use ozone. You have been shown how ozone is created and the life cycle of an ozone molecule. Ozone is safer than chlorine, ammonia, and other commonly used sanitizers when used as directed as a part of a managed cleaning and sanitation program. One of the many advantages of Ozone International's equipment and whitewater solutions is our patented methodology of equipment sanitizing and cleaning in place without shutting down production. This includes the use of handheld, dual-stream spray guns for cleaning and sanitizing, which benefits cleaning and disinfecting of hot spots during breaks and shift changes. Handheld spray guns for sanitizing only, spray bars for continuous belt cleaning, direct product application, and many other in-process equipment and product treatments. Additional advantages are ozone leaves no harmful residue that would need to be removed from the wastewater after treatment. Ozone is generated on-site, and thus there are fewer safety problems associated with shipping and handling. Ozone can be applied in an aqueous solution or gaseous phase to decontaminate food contact surfaces, sanitize equipment, sanitize water, and decrease pesticide levels on fresh produce. The microbiological quality and shelf life of vegetables, fruits, cheeses, eggs, nuts, and meats can be improved when these products are directly treated with ozone or stored in an ozone-containing environment. For fresh produce processing, ozone can be used to sanitize processing water or to decontaminate the product itself. The use of ozone in the gaseous phase helps in controlling mold and bacteria both in the air and on the surface of the product. National Institute for Occupational Safety and Health, the Occupational Safety and Health Administration, and the Canadian Centre for Occupational Health and Safety regulate employee exposure to ozone gas through its air contaminant standard. The permissible exposure limit is 0.1 parts per million over an 8-hour period. If high ambient levels are detected, the permissible exposure limit is 0.3 parts per million for a 15-minute period. The EPA, NOAA, NPS, tribal, state, and local agencies monitor the current ground level ozone concentrations that are throughout the U.S. and Canada. Areas highlighted in yellow have real-time ambient ozone levels that reach up to 0.075 parts per million. Areas highlighted in orange can have ambient ozone levels that reach 0.095 parts per million, and in rare cases, there are areas that can reach as much as 0.115 parts per million. Normal occupational levels that can be expected under normal conditions within the plant average approximately 0.02 parts per million to 0.05 parts per million, well below the OSHA permissible exposure limits of 0.1 parts per million. Ozone International recommends the use of one or combination of these ambient monitoring devices. The AM10H is a small, handheld monitor that gives an LED display indicating low, medium, or high ambient ozone levels. The AM20H is a handheld monitor that provides a digital output with alarm set points. The AM20W is a wall-mounted monitor that provides a digital output with alarm set points, visual flashing light, and an audible alarm to warn of higher than acceptable levels of ambient ozone. Ozone International uses the AM50 for cold storage applications. This monitor uses UV light to monitor the current levels of gaseous ozone in a controlled cold storage facility. The situations that may cause elevated ambient ozone levels include, but are not limited to, confined areas with no ventilation or air movement. To avoid elevated ambient ozone levels, Ozone International recommends that you only use aqueous ozone in well-ventilated areas. Avoid confined spaces with no ventilation or air movement. Avoid running your ozone system for prolonged periods of time in a clean pre- or post-production environment. Applying aqueous ozone during non-production hours may create higher than normal ambient levels. Ozone International recommends that the ozone generation equipment does not run in an empty, clean room for prolonged periods. Improper applicators. Use only spray guns, wands, and nozzles approved by Ozone International. Ensure that all applicators are clean and clear of debris that can cause the dissolved ozone to mist. This condition will cause the ozone to off-gas and can create high ambient ozone conditions. The best method to avoid high ambient ozone conditions is to operate in well-ventilated work areas and use approved ozone applicators. If at any time a high ambient ozone condition exists, inform your shift supervisor or management immediately. The following steps are to be done by trained, qualified personnel. First, obtain a handheld ozone monitor. Monitor the affected area with the handheld device to determine the source of higher than normal ambient ozone. Verify ozone reading and system set point at the ozone generating equipment. This should be done by trained, qualified personnel only. Determine corrective action based on the findings. If corrective action cannot be determined, shut down the ozone system and call maintenance or Ozone International for further investigation. Ozone International has designed their equipment to meet and exceed OSHA personnel safety standards. This involves materials used to protect against possible leaks and software settings to ensure personnel and product safety. Do not alter or reprogram any settings without consulting with Ozone International first. We have discussed that ozone, when used as prescribed, is safe for use in the food and beverage industry. We have shown you that ozone in the gaseous form can reach up to 0.115 parts per million in our day-to-day living conditions. OSHA and the Canadian Centre for Occupational Health and Safety occupational exposure limits are 0.1 parts per million for an 8-hour period and 0.3 parts per million for up to 15 minutes. We briefly discussed the discovery of ozone and the industrial uses of ozone. Thank you for your time and attention during this presentation.